Okay, so we're going to take a look at some of the skills that we acquired yesterday, hopefully, with completing the square. One thing I want to bring attention to, with factoring, when you're solving by factoring, you are getting one side equal to 0. But in this case, you have one side equal to the constant, not 0, right? So to the constant part of that trinomial. So in the case of the first one, we have it equal to 15, not equal to 0. And the second one equal to -2, not equal to 0. And so when you complete the square, you're going to have to make that situation. Because we're going to create a new constant. We're not going to work with -15, right? We're going to work with something that is a perfect square that we're creating. So just keep that in mind. Okay, so I'm going to walk you through the process as I did yesterday. Start here. X squared plus 14x plus blank equals 15 plus blank. So, what's going to go in the blank? 49. How did you do that? 14 divided by 2 is 7. 7 squared is 49. So now I've created a perfect square trinomial that I can factor. This factors to be what? Yeah, x plus 7 quantity squared. Perfect. And that equals 64. I believe this was actually a problem that we had yesterday. Now what do? Now we square root, introduce the square root. So what am I going to set x plus 7 equal to? Yeah, plus or minus 8. I have two equations. Plus 7 equals 8. X plus 7 equals -8. Subtract 7, subtract 7, subtract 7, subtract 7. So x equals what or what? 1 and 8. Alright. Question. Next one. Same process here. So in this case, x squared minus 4x plus blank equals -2 plus blank. What's going to go in the blank? 4. Thanks. 4. So this factors to be x minus 2 quantity squared equals 2. And then square root. So I have x minus 2 equals plus or minus square root 2. Okay. Now, I didn't tell you to approximate, so what is this going to be? X equals with one of your answers. Yeah, square root 2 plus 2 and negative square root 2 plus 2. If I had to approximate, that would mean just plug it into your calculator and then tell me what the approximate answer is. Which I believe your book has it in. Your book has you approximate your answers. So for the book, you'll have to just go a step further, plug it in your calculator, and get a decimal approximation. Okay. Any questions? All right. We're going to continue our notes. It's not new. So before, when we were looking at factoring, we would factor this and we would say, okay, I have a GCF. What's my GCF? 2. I would pull out a 2. is this factorable? Is there something that multiplies to be -4 and adds to be 10? No. So before we would say that's not factorable and we would move on, right? Not that it had no solution, but that it was not factorable. Well, it has a solution. We can find that solution now by doing what? Easy. Completing the square. Okay? So in some instances, like I said yesterday, something that may not be factorable may still have solutions that you can find by completing the square. So that's what we're going to be doing. So what should I do to get this to look like something similar to the bell work? Yeah, exactly. Add 8 on both sides. So that's what I'm going to do. So now this looks like something similar to my bell work, right? I have something of the form ax squared plus bx equals b. Now, does the GCF still come into play? The answer is yes. But you don't want to pull out the GCF, and this is very important. You do not want to pull out the GCF until you have it looking like this. When you have it in the form ax squared plus bx equals c or d or whatever, the constant, then you can pull out the GCF. Okay? So what is our GCF? 2. Okay. So when I pull out a 2, essentially I'm dividing everything by 2, right? So that's what I'm going to be doing. I'm going to be dividing each of these terms by 2. So x squared plus 10x equals 4. Does that make sense? So far. So again, one big thing that you want to be aware of, and that I'm going to have to reiterate here, is do not pull out the GCF at the start. Pull out the GCF if you're completing the square. In the second step, once you get it equal to a constant. Okay? So now I can continue as I did before in the bell work and solve this. So I can say x squared plus 10x plus blank equals 4 plus blank. What's going to go in the blank? Yeah. 5. 5. This factors to be x plus 5 squared. That factors to be x plus 5 squared. And that's that equal to 29. There's a reason why this wasn't factorable. And the reason is we don't have very nice numbers, right? So we still have solutions, but we may have like root 29 minus something, or something that's not just a simple fraction or a whole number that we normally are used to getting when we factor. Does that make sense? That's why we have to complete the square. So now I'm going to do as I did before, and I'm going to square root both sides. At this point in the game, you should not be forgetting the plus or minus. On the quiz, that's okay. And I'm going to curve it based on the highest score in the class. So when you get those back, those will be curved slightly. And it's okay that you didn't get it then, but starting at this point, you should really be remembering when you introduce that square root, because you've done it so many times, your plus or minus. So now we have x plus 5 equals plus or minus square root 29. And then I do exactly what I did in the bell work. I subtract 5 from both sides. So 1 is x equals root 29 minus 5. And what's the other one? Yeah, negative square root 29 minus 5. Okay. If I wanted decimal approximations, again, take square root 29 in your calculator, subtract 5, and you get approximately questions on this? So a couple new things. To get something like this, don't start if I say that you can solve it by any method, then you can start by factoring. And if you get to a position where it's either too hard to factor for you or it's unfactorable, then you're going to have to solve by completing the square. So I will not give you something that's no solution on the exam. So they're all going to be solvable. So if, again, you can't factor it, solve by completing the square, get the constant on the other side, factor out the GCF, and then do as we've been doing. Questions? I feel like this is okay. Alright. Even if you ever feel like overwhelming. Alright, so let's do another one. I'm going to have you try that one. Try that one. See how far you get, and then we'll go over it. Okay, so what do I do first? Yes. Yeah. Subtract 27. 3g squared minus 24g equals negative 27. Okay. Now what do I do? Yeah. What's the GCF? 3. So divide everything by 3. So I divide everything by 3. I get g squared minus 8g equals negative 9. Now what? Divide negative 8 by 2, square it, add to both sides. This is g squared minus 8g plus blank equals negative 9. And the blanks, we have what? Alright, factor this out. What does this factor to be? 2 minus 4 quantity squared equals 7. Okay, now what? Now square root. Square root. Introduce the square root, so I have g minus 4 equals root 7. G minus 4 equals negative root 7. G is equal to what? Yep, square root 7 plus 4. And what else? Negative square root 7 plus 4. Questions? All right. Okay, so we talked about one way that completing the square is useful when we cannot factor something. The other way that I mentioned yesterday was having to do with the graphs themselves. We're not going to go into too much detail until chapter 8, but what I want you to be able to do on the exam is to tell me what the vertex is. Be able to put something in vertex form and tell me what the vertex is of the graph. As far as actually graphing it, we'll look at chapter 8. And again, what do I mean by vertex? That's going to be that bottom point. Either the bottom point or the top point. Is it going to be a minimum if it's the bottom point, or a maximum if it's the top point? So we have we have a formula, a general form. It says that y equals ax minus h squared plus k. We've seen something like this whenever we were looking at absolute values last semester. last semester we said that y equals a times the absolute value of x plus h plus k, right? Except instead of parabolas, we have the V shapes. Well, what was the vertex for this form? HK, right? The opposite sign of whatever was on the inside and then the outside. You think that's changed here? No. Your vertex is still HK. And it's still the opposite sign of what's on the inside here. So, you're looking at all these different things and you should be seeing patterns. Whether it's exponential functions or absolute value or parabola, you're going to have an H and a K. Most often you can pull out the vertex for absolute values and parabolas by putting it in a specific form. And we call that vertex form, right? So H and K. Now as far as minimum and maximum value, that minimum or maximum value, and this is also very important, is going to be that K value. Whatever that K value is our minimum or maximum. So you do want to note that that is a minimum or maximum. Do you have any questions before we look and see how to put something in vertex form and actually find the vertex? I know we've learned a lot in this chapter so far. Cube roots, square roots, simplifying radicals, adding radicals, subtracting radicals, multiplying radicals, plus completing the square. It's a lot, but we have 2 days of review. You'll be okay. So I want to keep reminding you that you'll be okay. When a question is asking me to find a minimum or maximum value, it's asking me to find the vertex first. Then whatever that y coordinate is our minimum or our maximum value. How do we do this? By completing the square. Well, this is what we do. We get it in the exact same form that we've been getting it from the bell work yesterday and what we've been doing previously. So we want to get the constant on the other side first. Okay? So I'm going to do that. I'm going to get the constant on the other side first. So this becomes y plus 1 equals x squared plus 4x. Alright. Now, I'm just going to continue to complete the square like I've done before. So nothing new, which is good. Plus blank. And then I'm going to add a plus blank here as well. So, y plus 1 plus blank equals x squared plus 4x plus 4. What is going to go in those blanks? Yeah, 4. So now, I have y plus 5 equals, what's this factor? Yeah, x plus 2 quantity squared. Well, now I subtract 5. And I put it in vertex form. So, y equals x plus 2 quantity squared minus 5. Now that's in vertex form. What's my vertex? Perfect, yeah. Remember, it's the opposite sign for your x's, right? That's whatever's on the inside is the opposite sign. So it's negative 2 to negative 5. What's my minimum value? Negative 5, right. That's y. So, visually, what does that look like? You can see we've found the vertex, right? Negative 2, negative 5, and it has a minimum at negative 5. So minimums have a minimum value. Your parabola has to open what direction? It has to open up. What do you think is going to change about this equation to give you a maximum value and make it open down? What do you think? What side? The side in front of the x squared, in front of the 4, in front of the constant. In front of the x squared. Okay? If you have a negative in front, okay, and let's go back one side here. What's going to end up happening is this is going to be a negative. And this A is just like this A that we've looked at before. It is responsible for stretches and compressions as well as reflections. But instead of reflections here, we're looking at whether we're going to have something that opens up or opens down. As soon as this A value becomes negative, and it will be negative if that coefficient until the first term is negative, then it goes from opening up and having a minimum to opening down and having a maximum. Does that kind of make sense? So, of course, there is an example right there. The negative ones are difficult to work with. I'm not going to lie. So, I want you to pay very close attention to this one. Ask me any questions as we walk through it. So first write it down, and then we will go from there. Okay, so before, when we were factoring, I would say factor out the negative first, right? But then, just like GCX, what do you think we're going to do first before we take out the negative? Subtract 7, right. Subtract the constant on both sides. Perfect. So before we factor out the GCF, before we take out a negative, we're completing the square. And I have to emphasize, we're completing the square. Factoring is different. If we're completing the square, I'm going to go ahead and subtract that 7 first. Before I take out the negative. Now, I'm going to take out the negative. When I take out the negative, what do I do with the signs? Switch. And this is the part that gets a little bit weird. Now we're at a point where we can complete the square. Okay. So, y minus 7 plus blank equals negative, and still in parentheses, x squared minus 2x plus blank. Alright, what is involved with this? What's going to go in this one? No. Is that going to be the same as what's going to go in this one? No. Why? Yes, exactly. Exactly. Because we pulled out a negative. So really, are we adding one or subtracting one? We're subtracting one. That's the confusing part. So when you pull out a negative, you have to remember, what does that negative do? Well, a negative, when you distribute it, that would be a negative one, not a positive. So that means that overall, you're subtracting a one. We just pulled it out. Do you understand that? Okay. So we have y minus 8 equals negative, and then I can factor this as b what? What does this factor be? x minus 1 RB squared. I saw that negative out front. And then what do? My last step to get in vertex one. That's what I'm solving for the value of the variable, but I want to get it in vertex one. Add it, right. So now I have this in vertex one. We're not going to talk about the transformations or anything like that. You're just going to tell me what that vertex is. No. 1, 8. Therefore, I have a maximum at what? 8. I know that's tough. Do you have questions? Yes. Yes. I will not give you very many. I will most likely give you one minimum and one maximum. Okay? One minimum and one maximum. As far as everything else, I'm not going to give you a ton of, that's why we took the quiz, right? So I can give you a ton of simplifying radicals. I'm going to make sure you know how to simplify a cube root, that you know how to simplify a square root, that you know how to add radicals, that you know how to subtract radicals, that you know how to multiply radicals, that you can complete the square, that you can solve by completing the square, that you can solve by square roots, and that you can find the minimum and maximum value. I'm not going to give you a ton of all those types of questions. Just enough to assess each different skill. Okay? Alright. Here's your table of contents. If you're watching the recording, you should be able to complete all of 9-4 now.